It's great. I won't feel rushed. Yeah.
Just normal for the time you
Okay. Right. I might put the lights out as well. Oh, thanks. Right, okay, I know it's slightly early, I suppose, to be thinking about December. But we've got this Friday, November, so it just so happens that the second of our meetings is slightly earlier, but of course the next meeting won't be until the quiz, which will be the 13th of December, so we'll be halfway through the month by that stage. So looking ahead, just switch this on first, as usual, we'll start off with the sun. The sun's still quite active. This is the view for today. Solar Dynamics Observatory. Not any particularly dramatic spots, we don't have any big ones at the moment, but there are quite a few active groups. This one here is one of the most active at the moment, but then we do have a few more just coming around again.
The sun seems more active, Brian.
Yeah, yes.
The sun has been for a while.
Yeah, because really usually at the peak there's the two hemispheres meet at different times.
Yes, it's quite marked.
Yeah, we can see there that all these big groups.
Solar cycle.
The southern hemisphere. And there has been a fair amount of flaring as well, but at quite modest levels, so we've not seen any particularly big aurora coming as far south as us, but some people further north have been seeing some aurora mottling and so on. So we never really know when we're going to get something big. There have been some coronal mass ejections over the past few days as well, but most of them have been directed away from the Earth, so we're probably not going to impact it. So we move on to the actual sun as we see it, sunrise and sunset times. Obviously we've got fairly short days, which gives us nice long nights, which is what we like at this time of year. So in the middle of December it's pretty dark between 5 o'clock in the evening and then up to 7 o'clock in the morning. December 21st is the winter solstice, so that's when we've got the shortest number of hours between sunrise and sunset. But you'll see if you look at the sunrise and sunset times, of course, although the overall number of hours shrinks towards that point and then expands again, it's not coming in symmetrically. So the earliest sunset is the week before the solstice, so this around about the middle of the month. And again, it's actually over quite a few days. The sunset's roughly the same, and then the sunset gradually starts increasing, but it becomes later. But the latest sunrise isn't until after the solstice. So by the end of the month into early January, we're seeing these later sunrises at about 9:15, and then gradually that changes again. Even into January, of course, we're still going to have dark skies. So that's the sun. Moon. We've actually managed to, because it's a long month, and we've got a new moon on 1st of December, a week on Sunday. We're actually able to fit in an extra new moon this December, so right at the end of the month, at the end of the 30th, there's a second blue moon. Yes, we had this discussion. What would you call the second new moon? Or really the fact that it's you can't see it, it should be a black moon. Perhaps we should call it the blue moon. So the main phases are quite nicely separated by a week. So it's all the Sundays in December up until that last new moon, which moves across into the Monday itself. So first quarter of December, then the full moon on the 15th. And of course at this time of year, although it's not quite as bad as it was back earlier in the autumn, sort of September, October, the angle of the ecliptic is still quite shallow with the horizon. So as the moon is moving away from you, it doesn't get very high at this time of year. So it's quite a few days after new moon before you begin to see the young crescent. Back in September, October, you might have to wait almost a week, and often it's first quarter moon before you actually first see it above the horizon. It's a few days in December, but actually the 4th, if you're lucky and have a low horizon, you might see the moon on the 4th, but it will be just slightly below Venus. So I'll talk about the moon first, and then I'll come back to Venus. So this is where it is on the 4th. This is the view for 4:20 in the afternoon, which is about 45 minutes after sunset, so the sky is getting reasonably dark by that point. The moon will be just 5 degrees up at that point. Venus is about 9 degrees. Venus is of course improving, it's getting a little bit higher now, so it's it must be a week or 10 days since I was first able to see it at this apparition. I've not seen it before that, although it had been around because it was setting quite early. but hopefully some of the others have seen it now as well. It's actually high enough up to see above buildings and trees and so on. So on the 4th of December, Venus will be a bit higher at 9 degrees up. So if you have a clear horizon, you might need to use binoculars, but you may well spot the crescent moon at that stage. The following night it will be much easier because it has then moved up to be about the same altitude as Venus itself. So 9 degrees up, and it will be out to the left of Venus. So that's when you should start looking out for the crescent moon in December. But yeah, Venus has been in the evening sky most of the way through the autumn, but it's always been very low and setting quite soon after the sun because of that shallow angle of the ecliptic. But now that's tilting a little bit more as we go through the winter, so Venus is gradually coming up, and during December it will increase in height significantly. As you've seen early in December, it's about 9 degrees high. By the end of December, it will be about 18 degrees high, 45 minutes after sunset. So through the Christmas period, we'll have this nice kind of Christmas star, if you like, over in the... It's actually almost in the south, is just here, just off the edge of the slide here. So it's actually really far around. When I saw it the other night, I was actually quite surprised how far around in what I usually think of as my south direction that I could actually see Venus. But it's obviously just because the sun is at its most southwesterly at the moment. So Venus is the first of the planets that you'll see in the early evening sky. Then we've got other ones scattered all the way across the sky. We've got Saturn, first of all, across here in Aquarius. It's now a few months past its opposition, but it's still fairly bright at magnitude 1, so it's relatively easy to see. As we go through December, it's obviously going to be setting slightly earlier. These times are for mid-month in December, so it's transiting its due south about 5:30 in the evening, not long after it's got dark, and then it's setting about 11:15. At the moment, it's about 6:30, I think, something like that, 6:30, 7 o'clock, that it's transiting, and it's setting just shortly before midnight. But by the end of December, it will be going down before 10 o'clock in the evening, and it will be basically be in the south as it gets dark. So December is probably going to be the last time that you're going to get reasonable views of Saturn against that kind of dark sky when it's at its highest, which is about 25 degrees up or so. About 12 degrees away from Saturn, to the upper left, is Neptune, which is also a few months past opposition, but its brightness level doesn't really change very much because it's so far away from us anyway. So it's about magnitude 7.9, so it is detectable in binoculars, so it's worth going out to see if you can pick it up. It's just across the border in Pisces, very close to the edge of Pisces, and it's obviously translating slightly later than Saturn, and setting slightly later as well. And then as we move across the sky further over here, we've gone to Uranus, which was at opposition last month, so it's still fairly bright, magnitude 5.6, easy to see in binoculars, almost on the verge of naked eye vision if you happen to have dark sky and good eyesight. So it's not transiting until a bit later in the evening, and doesn't set until just before dawn. It's also about 5 degrees to the lower right of the Pleiades, which is about a binocular's field width, so it's quite easy to find where it is at the moment. You see Jupiter shown there as well, which is sitting in Taurus at the moment. Essentially, that Uranus is actually technically in Taurus just now, but it's just over the border from Aries. But actually right at the end of December, in fact at the moment it's in retrograde, so it's moving westwards across the sky against the stars because we are overtaking it on the inside as we go around the sun faster. So it's moving in this direction, and at the end of December it actually goes back into Aries again, and it stays in Aries until it starts moving forward and eventually comes back into Taurus in about March, early March. So Jupiter, if we move forward, Jupiter is at opposition this month. Oh, sorry, she is at opposition in December. On the 7th, when it will be at magnitude -2.8, nice and bright. But I'm sure everyone's seen Jupiter, at least on the sky, even if it hasn't been through any particular telescopic instrument or binoculars. So it is very, very bright. It's amongst the stars of Taurus, so we've got Aldebaran and the V-shape of the Hyades here, and it's the Pleiades with Uranus just up here. So Jupiter's nicely placed directly above Orion and not far from the bottom of Auriga. So because it's at opposition, it's pretty much rising as the sun is going down, and it's at its highest around about midnight and then setting at dawn again. So we've basically got it all night, and it is very high up. It's right up at the top of the ecliptic. So if you're out imaging around about midnight or even shortly before midnight, you're going to have a nice high Jupiter. Alternatively, you could wait until into January when it's transiting a little bit earlier.
Wait till January.
And then finally, of course, we also have Mars at the moment, so all of these planets are visible in a sort of parade across the sky. So we've got, there's the edge of Orion, Betelgeuse and Bellatrix, so Jupiter's just up here. And then further across we have Gemini, Castor and Pollux, and then here's Mars down there. Mars is at opposition in January, on the 16th of January, so we've still got a wee bit to go, but it's definitely been brightening up over the past few months. So it's during December, its average magnitude is about minus 0.8, and it's rising in the middle of the month, not that long after it's got dark, but still not transiting until the early hours of the morning, so it's still quite low in the first part of the evening. It's pretty small. These oppositions that happen in the early part of the year, kind of January, February time, are when Mars is at its most distant from the Earth, so it's pretty small through a telescope. And what I've seen of it so far, because it's been low as well, it's been pretty fuzzy. But it's interesting, it's in this sort of gap. There's Castor and Pollux and Gemini up here, there's the head of Leo down there, and then you've got what almost seems to be in the sky, because with most urban skies you can't really see all these faint stars in here. It looks like an empty patch of sky, which is Cancer the Crab, not containing very many bright stars. But just below in the centre of Cancer, that's the Persepi, or the Beehive cluster. So Mars is going to be passing just above the Beehive. So in binoculars you're going to get a nice sort of pairing of Mars and the stars of that particular cluster. But I'll say more about Mars when it comes to January. But it'll be much brighter and a little bit bigger, but a bit more prominent. If you do fancy a challenge with Mars, particularly if you've got a slightly larger telescope, it's a bit bright, there is actually an occultation of Mars in December, but it happens during the day. You may remember a couple of years ago when Mars was at opposition last time in December, it was an occultation. It was in the early hours of the morning, so you had to go at 4 AM. It was full moon because it was on the same night as opposition. This one is the moon's just past full. It's full moon on the 15th, so it's a few days past full. On December the 18th, so we've got a waning gibbous moon, but it's a daytime one. But magnitude almost minus 1. Mars should be visible with the fact you've got the moon to help track it down. It may well show up. So its disappearance is at 19 minutes past 9 in the morning. The moon's way around in the west-northwest at this stage, so it's quite far around. It's only 15 degrees up, so it may not be a particularly good direction to see it in. And then reappearance is just under an hour later at 11 minutes past 10, when the moon's only 8 degrees up. And it's moved about 10 degrees in azimuth around, so it's not particularly ideal, really, the combination of where the moon will be and the fact it's in the day. It might be a bit tricky, but anyway, just out of interest, I'll mention that's happening. So the final planet is Mercury, which at the moment in November is in the evening sky, but it's setting really soon after the sun, so it's almost impossible to see at the moment. But there is actually quite a nice morning apparition in December. So it's at inferior conjunction on the 6th, when it moves between us and the sun and moves from the evening sky into the morning sky, and it then swings out to its greatest elongation west of the sun on December the 25th, on Christmas Day. But the way that this works, it actually is at its highest above the horizon for us just a few days before it's at greatest elongation. So this is the view for December the 20th. Again, the advantage of a wintertime morning apparition for Mercury is the fact that you don't actually have to get up that early to be able to see it. So this is the view 45 minutes before sunrise, which is 8 AM, and this is looking to the southeast. So here's Mercury here. We're at 7 degrees altitude at that time, so it's quite low. It will obviously get higher before sunrise, but the sky is brightening as well. So if you have binoculars, you could probably spot it later than this. But actually, even 45 minutes before sunrise to be 7 degrees up is quite good for Mercury. And it is, overall, it's rising about 2 hours ahead of the sun at its best. So it's the solitary morning planet at the moment, in terms of only morning. I suppose some of the other planets are still visible at that time. So those are the planets. Regarding the stars, the star map for December, this is for the middle of the month, around about 9 PM. We're obviously beginning to lose the summer triangle now, they're very low over in the northwest. Altair will disappear below the horizon. Both Deneb and Vega are circumpolar stars for us, so they do stay above the horizon all year, but as we go through the second part of the winter into the spring, they're very low above the northern horizon. But of course they are replaced by all these spectacular wintertime constellations. So we've got Orion and Taurus, Auriga and Gemini all coming up over there in the southeast. And then up overhead, the Milky Way running through Perseus and Cassiopeia as well. So it's a fantastic area to look. You've got a pair of binoculars, lots of open clusters and things to look at along the Milky Way. To the north, the plough is beginning to stand up on its handle, pointing the way up to the pole star, of course, and then through that over to Cassiopeia. In the south, it looks pretty dull in that direction at this time of year. Below Pegasus, we've got Aquarius, Cetus, there's Pisces is just in here as well. But if you've got a kind of urban sky, you probably won't see many stars, just like a big black patch above the southern horizon. So these are all pretty faint constellations. Although they do contain some interesting objects. So that's our view for December. And then just to finish off with a few things to look for, I always like to try and think of some kind of difference. So I was thinking, well, Jupiter's obviously in Taurus. I have not taken a photograph of Jupiter in Taurus yet, but what I did find was one of Mars in Taurus, which I took at the beginning of 2023. So this was 2 years ago when Mars was at opposition in Taurus. So this is Mars up here, but then of course we've got the head of Taurus down here, the Pleiades. So there's Aldebaran, which is the Alpha Tauri, the brightest star in Taurus. Magnitude 0.85. It's very slightly variable, but not by very much, so we don't really see visibly much change with that. But this is an interesting part of the sky to look at if you'd like to try and view things in 3 dimensions, because in a small area of sky you can actually see objects of different distances, because usually when you're both looking at the sky and looking at images, you tend to think of it as the ancients did, it's the dome of sky and everything's pretty much the same distance away. So Aldebaran's actually a relatively nearby star, red giant star at 65 light years. And it fits quite nicely into the group of stars that make up the head of the bull, the V shape here, and it kind of quite nicely is an opposite to this star at the end of the horns on that side. But these other stars in the group are all part of a cluster called the Hyades, which actually lies, the group is a genuine cluster, lies at a distance of 153 light years, so it's a bit over twice the distance of Aldebaran, so it's just pure coincidence that we see Aldebaran as part of this pattern. In fact, when I was looking at this, I was thinking, actually, if you took away Aldebaran, would you actually see that as a V shape or not? Or would your eye actually connect it in another way? It's just interesting that it just seems to perfect
in a
that V shape.
In the light blue sky, you will see easier because they won't have confusion with fainter stars there.
Yeah, that's right. You don't see quite as many. So that's one step out you can take. Try to imagine Aldebaran in the near hand and these other stars a bit further away. Within the Hyades, one other pair of stars that's interesting to look at is Theta 1 and Theta 2 Tauri, just down here between Aldebaran and the point of the bull's head. A nice pair of stars, one white, one yellow, quite bright, magnitude 3.4 to 3.9, and they're 5.6 minutes of arc apart, not seconds of arc, but minutes of arc. So it's about a tenth of a degree. So if you've got good eyesight, you might actually be able to split those two with the naked eye, but they're very easy in binoculars, and you get the colour contrast if you're looking at it in binoculars as well. So highlight those is something interesting to look at within the Hyades. And then of course we have the Pleiades as well. I don't really know what to say about the Pleiades, it's such a familiar object, an ideal binocular subject I always feel, because they fill the field of view of binoculars quite nicely. If you use a telescope, the field of view is normally so small that you only see a few of the stars at a time, so to get the full impact, looking with binoculars is definitely the best. The naked eye, of course, you can see usually 6 stars. There are 6 obvious bright stars. The 7th one up here is slightly fainter, it's quite close to the other, so you need to have a slightly better visual acuity to be able to separate them. And in fact, what you usually find is that there are other stars of the same brightness as that 7th one, And if your eyesight is good enough to see beyond the main 6, you can often see 8 or 9. You won't see just 7, but you can obviously see a few more. So it's quite a good test of your eyesight. It's a nice clear night when the Pleiades are high in the sky and you're not old like me and losing your eyesight, to see how many naked eye stars you can actually see in the cluster. The Pleiades are 440 light years, so about 3 times the distance of the Hyades, so they look slightly smaller and more compact than the Hyades because they're further away. So again, you can maybe try and think of that additional step looking off into the distance. The brightest star, Alcyone, or Eta Tauri, is this one just here, at magnitude 2.9, and the main kind of bright ones go down to about the 5th magnitude within that kind of naked eye range. If you're looking in binoculars, I'm not sure how obvious they are to the naked eye, they're a bit faint, but this little chain of stars going down here is really obvious when you look through binoculars. And it's interesting that if you look at Galileo's drawing of the Pleiades, which is one of the early drawings of a star cluster that he did, he's drawn that really prominently in his drawing as well. So it is something that really stands out when you're looking at a small instrument at the Pleiades. So there you are, so you can think of 3 dimensions, if you can, with Aldebaran, then the Hyades and the Pleiades off in the background. So they're quite familiar objects. I always like to encourage you to go out and look for things that are a bit different and not be going out and always looking at the same old familiar faces each year. So there's a couple of other open clusters, possibly, that are worth looking at in Taurus. This is NGC 1647, which is not far from the main head of Taurus in here. Nice little compact group of about 90 stars, magnitude 6.4, so easy to see in binoculars, and it does show up as a nice small fuzzy patch in binoculars. It's even further away, so if your brain can stretch to 1800 light years off in the background, then it's at that distance across there. And then right up in the top corner up there, we've got NGC 1746, which is a numerical anagram. See this one here, 1746. It's a much looser grouping, much more spread out of about 20 stars. I couldn't find a published distance for this one, but it's possibly because there are a few papers being published suggesting it's actually an asterism, it's not a genuine cluster, and that the stars that make this up are actually all at different distances away from us. It just happens to be there's a kind of density of stars along our line of sight in the Milky Way in that direction. So we're seeing them, to our eyes, grouped together, but it's actually an unassociated grouping of stars. The combined brightness of the group is given as 6.1 magnitude, but I feel that it's so spread out you don't really get that effect that you would with a more compact cluster. So through binoculars, it does look like a nice scattering of stars, and it's definitely, I think, a binocular object because of the area of sky that it covers. So if you are out and tempted to have a glance up at the Hyades or the Pleiades, see if you can find these 2 other clusters as well, which are slightly different in form from these ones, more familiar ones. So there we are. So that's some suggestions for your observing challenges for December, if we get decent skies anyway to see anything. Geminids this year fall just before full moon. Full moon's on the 15th, so it's going to. I did say not say anything to the Geminids really because it's just the sky is going to be so bright.
It's such a good
fall down.
shower.
They were very good last year because they fell with a. I can't remember whether it was first quarter or last quarter, but certainly it was a nice dark sky.
Good one.
But yeah, I'm afraid this year it's very close to full within a day or so of full moon, so so we're not going to see much with that. I think the Ursids are slightly better, but they're December the 23rd. Don't see very many of them, and people have got other things in their mind on the 23rd of December. They go out observing for details. Any other questions or comments?
That's great.
That's great, yeah, that's
Okay. Wish you all clear skies, and if anyone does manage to do any imaging or observing of any of these objects in whatever form, whether it's photographic imaging or drawing or whatever, remember we're always happy to show off those at future meetings.